For this 8th workshop, we are having close to 100 participants representing 18 countries. So we certainly appreciate all of you coming and participating. The way the sessions are going to be conducted is that the moderator will introduce the speakers, and we will save the question and answer period for the end of the session. I would like to recognize the chair of past workshops. I think Jim Cagley, were you the first chair? And he was followed by Jim White. Jim White at the time was the chair of Committee 318 and was a vice president. And it is a privilege for me to be filling after these big shoes, their big shoes. I would like to thank the speakers ahead of time for taking the time to prepare, and for the young practicing engineers for coming. It's a pleasure to have you, and we welcome you, and we look forward to your presentation. Okay, at this time, as you notice, I'm watching my watch, and the reason is, as was announced, there is going to be a webinar that starts promptly at 8:30. And I am told that we have registrants from many cities around the country that are sitting waiting now for this seminar or webinar to start, and they will be participating via questions that they will email to Claire from staff who is helping here. Okay, so with this, let me introduce the moderator for the first 2 sessions of this morning. It's Poston. Randy is the current chair of ACI 318. He has the big task of leading the committee into a major reorganization of the code, and I will let Randy and his speaker tell you about what's going on. And with this, I wish you a successful workshop and a productive one, and have a good couple of days. Thank you, and Randy.
Thank you, Basile. It's my pleasure to be here to moderate the session. I will also be giving the first presentation, and I think the first session today is really to kind of capture what the committee has been doing over the last six years. We're going to start out in a general sense, get more specific in terms of what we really did and how the code is reorganized and how you will be using this reorganized code once it has been published. Of course, this is a big job. Although I'm chair, we've had just some very terrific, the whole committee's been terrific in moving this forward. The various subcommittees, it's been an interesting time and an interesting structure that we had to have in order to do this reorganization. So I will do the first presentation, and one of the most basic questions we get asked is why are we doing this? And so I want to kind of give you a perspective about that, a little bit of the philosophy, how we arrived at the decision to do what we did, and I think that will give you then some ability to review as we get into the other presentations of how we took these recommendations and moved it forward into an actual code. So my presentation's the reason the Committee 318 is reorganizing the code. So first of all, I want to give you a brief history about 318 and the committee and the code itself, how we've gotten to this point with in the last code cycle with 318.11. Tell you a little bit about Committee 318. People often think it's a mysterious group. It is in a lot of ways. And I want to describe who the makeup of this committee is. I guess most importantly, I want to describe why we are reorganizing the code, and then a little bit about this process. After I finish my presentation, the next one will be more specific and getting into the nuts and bolts of the reorganization. So here's a little bit about the history. I dare say these 5 gentlemen, there's probably more ties on this photograph than there are in this room right here. So I want to make note of that. It's certainly got a long legacy with Re18 and giants in the industry that have led the process of in terms of Re18 and the code as it exists today. One of the earliest codes, as you may know, is the Code of Hammurabi. The actual stone or monolith is in the Musée du Louvre, or the museum in Paris. Dates back to about 1750 BC, and it's a kind of is one of those things that structural engineers and people working in the construction industry in terms of building codes always points to as the early code. It was interesting. I got to visit Paris really for the first time last year, and I took a very close look at this stone, and it was amazing what I was able to see. I had a cryptologist there with me, a specialist, and when I looked at it, it said ACI Committee 318 shall reorganize the code in 2014. So there it is, right there. Some almost 4 millennia ago, there was a discussion about how that 318 was in fact going to do some sort of reorganization. I found that very prophetic. That such long ago that we were led on this path of what we were doing at this time. Put it in perspective, the first code that you will see here in a moment was in 1904. It was the National Association of Cement Users. It happened to be the same time as the World's Fair in St. Louis. We were going to be looking at in 1904, you had the World's Fair, you had a number of other things. We were talking about a railroad exhibit, an electric display, an 8,000 horsepower turbine engine, and a bunch of other things in 1904. Now the American Concrete Institute is headquartered in Farmington Hills, Michigan, outside Detroit, and certainly the Institute has had a long history in the Detroit area where it exists today. So this is the first building code for reinforced concrete. A lot of people would say this is what we need to go back to. It was 14 pages long. It clearly defines, when you look at the first item, what reinforced concrete is, the classes of buildings and construction in which it can be used, height of buildings, and so forth. So it's a very general code. Is not overly prescriptive, maybe more performance-based, some that people would say. So we've got a very elegant 14-page code that really defined the practice in 1910. Of course, all the building codes, what is the reason we have a building code? It's first and foremost, the goal is life safety. We have minimum requirements to ensure that we have integrity of a building, that we ensure that we have life safety. We do have other requirements, obviously, at this point, to ensure that we meet some of the other, what we term limit states, such as durability and serviceability. But the main objective, of course, is life safety. This is, of course, a very interesting photograph when we look at reinforced concrete, and we typically design for 150 pounds per square foot or 100, and you get a sense of this type of structure, warehouse, or whatever. Whether it was designed for 100 pounds, it looks like it's taking substantially more. And that's one of the virtues, of course, with concrete, is the overall integrity of the system. This really points to the Code of Hammurabi, what it said. If you design a structure, you better be willing to put your life in hand. I think this person down here, my guess is he probably drew the short end of the short straw and was asked to go in there. It's certainly a very classic picture, but very much describes this idea of, in terms of engineering of structures, really what we're trying to accomplish. And that, of course, is life safety. A little bit, we're going to have a presentation. The third presentation in the morning session is going to be interesting because it's going to deal with some very, very nice things that the committee has been doing in terms of progressing our use of electronics. Of course, I was of the era. I'm certainly don't feel like I'm that old, but I certainly started out my engineering career using a slide rule, and then advanced to the HP41C that we have here, and everyday use now, people are using either their mobile phones or iPads or other type of devices in order to be able to quickly access information. So our building code is trying to adapt to that technology as well, and as well it should do. The code, again, in 1910, the National Association of Cement Users, we had these 14 pages. The ACI 318 code, as the committee formulated it, first began in 1947. In 1956 was a code based on working stress. In 1971, two things happened. The code went to ultimate strength, an LRFD type approach, and then the other is that a commentary was added. So that was really the first time that we had kind of a split code where we had commentary that went along with the code. In 1983, we went to the new format where you had both the code and commentary side by side, and that has evolved the same way over the years. So at this point, we're at some 500 or so pages, and we're that ideal of this 14-page code to something over 500 pages. We know that technology changes, things has to be added, but part of the issue in the discussion of reorganization is how do we find that information to make sure that we in fact have satisfied the code. So 318, of course, as an organization has been up to this point based on the behavior of reinforced concrete. We had chapters on flexure, we had chapters on shear. We did have some member-based chapters such as foundation, but for the most part it was behavioral based. Through 1956 it was based on working stress, and then with the addition of the 1971 code moving forward, we were established and entrenched in this concept of ultimate strength. So essentially the current code organization has its roots back to the 60s as it was first published in 71 with ultimate strength based on the reinforced concrete behavior. And since that time we've been adding provisions as we've gained information, as we've done research, learn things, detailing requirements, integrity provisions, and so forth over that time. And so that what you see is a collection of experiences of the committee and practice that have evolved into the 318-2011 code. That early 1971 code had about 750 provisions separated by a code and commentary, and in 2011 we have more than 2,500 provisions at this point. Not necessarily something to be proud of, but it's a fact. We have a lot of information that has been added over time into the code. Well, what are the significant changes that have occurred? The reason why we've had to provide additional information in code direction to the engineer. Well, a lot of work in research and in practice on development lengths of bars, and certainly as bar strengths have increased in other types of high performance concretes, those lengths have changed, so the experience had to be reflected in the code provisions. There had at one time no requirements for torsion or torsional strength in the code, and those have been added. Certainly one of the significant measures is seismic performance and design and detailing requirements, which takes an entire chapter in our code presently. The concept of integrity reinforcement, that is one virtue, if you will, of concrete, that in order to provide integrity, it's a fairly easy thing to do with some modest amounts of reinforcement that engage principal structural members and lead, if there is such a thing as a collapse, to a column. Another very important concept is the idea of concrete exposure classes. We had been kind of going around what the real issue is of durability, and now the engineer, the designer, defines up front in his project what the exposure class is, which then leads them to material requirements for the project. Strain-based strength reduction factors. Before we had, whether it was flexure or axial load, it was simply a fee factor that was associated with those types of behavior, or now it's a kind of a transitional, depends really on the strain, which of course makes more sense in terms of whether it's a ductile behavior or a more brittle type behavior. And then lastly, anchoring to concrete. Whether anchoring to concrete is should be in the code or not is subject to a lot of debate. We have it in the code, and as that has progressed, we have added different types of anchors, from post-installed anchors that are the mechanical variety to most recently in the 2011 code, adhesive anchors, and that really came out of the experience at the Central Artery Tunnel in Boston. I think one of the things that may be a little bit of a misnomer for folks is that 318 we typically think of being a code for the United States, which certainly it is, as it's adopted into the Model Code, International Building Code now, but really it's used extensively around the world in various pockets. We have a large use of the code in Latin America and South America. We have fairly extensive use in the Middle East countries, and we have some use in Asia, and then in the South Pacific in New Zealand and Australia. So the code 318 is truly an international code. One of the things that has happened is that we're part of the ISO process, and it has been adopted as a code that can be used by any jurisdictions because we meet those requirements of ISO TC 71. So we have a big, broad use of the code throughout the world. The ACI Committee 318 is made up of a variety of people. We want, as we engage people in this process, we don't want to have just designers or academics. We try to employ a wide variety of people: structural engineers, materials engineers, and building officials. I want to note that this marker is wrong. I think this is pointing to Tony Fiorato. I'm not sure whether he's a materials engineer or structural engineer, but he did provide a good place for us just to put an arrow, and so we called him a materials engineer. So it's a variety of people that work on a consensus-based process to deliver this code. It's an expert committee. I feel that we meet certain requirements by ANSI, which deals with the consensus-based process and what we have to do to gain consensus, which is what we follow. It's a very rigorous process. The ACI technical review process, not only do we have to get consensus within the committee, it's reviewed by the Technical Activities Committee. The committee responds to those comments. We will be going through that process here very shortly. And then there's a public comment period, and followed by a response to those public comments. That will be occurring sometime next summer. Again, the diversity of the committee, I think, is part of its strength. We have a variety of individuals who work in industry in a variety of capacities that really makes this process work. Again, the scope is international. We have, I believe, on the present time, something like, I want to say it's maybe a dozen or so countries represented on the 318 building code in various capacities, either as subcommittees or on the main committee. So it's we do have some international diversity as well with the 318 building code. One of the challenges we found in trying to go through this was, how do we divide up the committee? Heretofore, the subcommittee structure really was focused on behavior of reinforced concrete, and then somehow, as you will see going through this process of reorganizing and making it more focused on members, we had to divide up how those subcommittees worked. And so although we typically say, for example, that subcommittee E is shear and torsion, in fact, they worked on a lot of different things this time around, including making what we will call a toolbox chapter, which Larry Novak will talk about here shortly, and a number of other chapters that they would not have been done by in a traditional building code cycle. So we've had to kind of redo, rework what those various subcommittees of 318 work on, and that's really where the workhorse of the group that built the building code. Well, let's answer this question: why did we want to reorganize the code? It's a topic that's been out there for decades, essentially almost 40 years now. Chet Cease, who was ACI president in 1974, had a paper about the code being too complicated, too complex, or both. He would, God bless him, he would roll over in his grave today if he saw probably what the code looked like with these 2,500 provisions and 600 and something pages. So not sure we went down the path of doing something that is less complicated and less complex and so forth. But the idea is there, and it had been talked about years and years of what can we do to improve the process for the engineering and construction community of concrete. Well, one of the things that became important, and I'll talk a little bit about, is how do you know when you fully satisfy the code? There's a lot of provisions in there. What we have found is that engineers, fully practicing engineers for years, would miss some of the provisions that they needed to design for, not because they just didn't know they were there. They were in other places in the code, and it became a little bit of a roadmap of what do I need to satisfy, for example, the design of a beam. The provisions were scattered throughout. So the code kind of assumed, and it's certainly true, that the user knew where all those provisions were located. And certainly when you're talking about 2,500 provisions, that idea to do that, it really taxed the user. Just as a brief example that we've been using for a detail of a column, you've got shear strength and flexural strength that has to be dealt with. That's in Chapter 10 and in Chapter 11. You've got reduction factors phi that are in Chapter 9. You've got to design the ties through the joint, which comes from Chapter 11. Certain detailing provisions of the longitudinal reinforcement in the column that are in Chapter 7. Lap splices that are in Chapter 12. The cover requirements in Chapter 7, and the conventional ties that you may have in the column also in Chapter 7. So you have 5 chapters for one essentially design detail. So through this reorganization process, why that kind of became the focus of what we were trying to do. So in 2003, it's been almost 10 years now, under Jim White, it was started to look at under a subcommittee called Subcommittee F. There were some informal discussions. In 2006, we got a little more serious about the business of what we wanted to do for reorganization. We did a survey. That survey showed that, yes, of course, the code is used for the design of buildings. It's also used for, we found out almost 50% of the people are using it for repair and strengthening code. You may know that there is now an ACI code for repair. So it's a wide variety of uses of this code that most people probably thought was only being used for the design process, in the design only. So the feedback we got was that engineers really wanted to relate the information that was in that code to the design and detailing, make it more easy for them in that design process. So they wanted that to be closely related to how they practice. When you figure about taking loads from a slab or a beam to columns, you're going to do that design through that process. You'd like to design that slab and know that you're done, or a beam, and so forth. So in 2006, with these focus groups were held with a number of structural engineers, we concluded that reorganization would be a benefit to the end user. And in 2007, a steering committee developed what was to be and where we're at now. It's changed quite a bit over time as we dealt with it, but in fact the outline does maintain a lot of what was envisioned in 2007. And then in 2008, the spring of 2008, we began the process in earnest, and this is where we're at now, some almost 6 years later in the process. So the overall goal is to improve the logic of information and the location for greater ease of use for the designer, to make it apparent to the designer that this is what you've got to do to complete a design. You don't have to go looking through all these various chapters and various provisions of the code. The advantage is that the user is going to know when the design is complete. He's going to have all of the detailing requirements that are required for that design at his hand for each member type. The other thing we've done is to improve the language and the consistency of how provisions are introduced into the code to have some uniformity and things like grammar and so forth. We've introduced a fair number of tables in the code to make it visually more appealing. And one of the other things that we had kind of de-emphasized as we were going through this, but I think became very apparent as we did this process, is that when new technology and research is coming on board that we need to add to the code, the format, this outline, is going to make it much more easy to add that information, to add these provisions to the code. So have a nice location when engineers on the next code cycles want to know what's changed. It's going to be very easy to identify using this format. So one of the other things as we're going through the process we learned is that there were obviously some gaps in what was in the code. We decided to add a chapter, so we've made a significant number of technical changes too, talking about structural systems, although it was always implied that we have a gravity load system and a lateral load system. It never really was said, so chapter 4 talks about structural system performance and what we're trying to achieve in building frames and building structural systems. The other is that we really never had explicit requirements for diaphragms. We designed slabs for one-way action, but we did not have any detailing requirements for lateral loads. What do we need to do for detailing and designing a diaphragm such that we get the loads out of the structure into the frame or the shear walls? And then also, it's very clear that we don't have adequate information in foundation systems. We've collected it in one place, but there's still going to be a lot of work that needs to be done related to foundation, and some of that's going to be having to interface more with International Building Code, what's in the International Building Code, what's in ASCE 7, and what's in the ACI 318 Building Code. So with that, I want to thank you very much for letting me discuss a little bit about where we're at in this process and why we're into this process. And thank you very much. Okay, hold on to your questions. I think the process Senor Bazia-Rabat told us that we're going to keep our questions till the end, so just kind of collect those questions and we will answer them. The second presentation this morning is by Larry Novak. He's the Director of Engineered Structures at the Portland Cement Association. Larry's been a practicing structural engineer and had the opportunity to be a part of the teams that worked on the Burj Khalifa and the Trump Tower in Chicago, so coming with a lot of very good design experience, been very helpful in this process of reorganizing the building code. So Larry, let me see if we can get you up here. Okay.
Thank you very much, Randy.
All right, thanks Larry.
Good morning, everyone. Oh, we could do better than that, I hope, at ACI. Good morning, everyone.
Good morning.
Excellent, excellent, excellent. I do realize it's early morning. I'm sure a lot of you had very long flights the last couple days. Heck, I'll even tell you a little story. I was doing a presentation back at my alma mater, University of Illinois, and it was a warm Friday afternoon. I think it was homecoming weekend, so the kids were especially tired. And I was doing a presentation on a building covering the details of a project very dear to my heart. And in the back of the room were these two students. One with ripped jeans, bandana, feet up on the desk, kind of got the imagery. And well, of the two students, one of the students fell asleep. I don't mind that. Heck, I've slept through a few presentations. I know that. That's perfectly fine. He started snoring loudly. So at that point, I finally had to ask the one guy with the bandana, ripped jeans, feet up on the desk, hey, can you nudge your friend and wake him up? He looks at me and goes, me wake him up? You wake him up. You put him to sleep. So at that point, I'm perfectly fine if anyone wants to take a nap. Again, Randy has tasked me, my name is Larry Novak, with a very difficult job. He set everything up. I have to talk about the details. Okay, let's start with, it's a code, and it's long, and I have 20 minutes. Okay, not going to succeed in everything we want to do, but we're going to try to make some headways into understanding what the new code will look like when it comes on your desk. And really, we're playing Terminators here. What are Terminators? Really cool cars that turn into robots, right? Or robots that turn into cars. But the key is it's the same kit of parts. Everyone with me? We've got two varied looking different things, but they start with the same parts. We are not, I repeat, not changing the way you design. We're going to keep the same set of rules. We're reshuffling the deck. And the reason that's important is if you know how to design, we're just going to make it easier for you to find provisions. We're going to make it easier for you to learn the code. We're not changing the basic concept of the code. And a couple guidelines throughout my presentation. If you see a number in red, we're talking about the 318.11 code. If you see something in green, we're talking about the 2014 code. Just kind of visually to grasp what we're looking at. So we all know our good old code, right? Be honest, I am a structural engineer. I design buildings. My neighbor thinks I can fix his car. Doesn't fully understand what a structural engineer does. I actually can fix his car, but I don't want him to know that. But if you take my code, it opens on its own to Chapter 7. And there's a lot of stuff in there that it opens on its own at the bent binder all the way up to about Chapter 12. Then it restarts at the seismic one. Why is that? Well, 7 to 12 are really our meat and potatoes, right? Our day-to-day stuff we use. And think about it. What is Chapter 7? Details of reinforcement. What's Chapter 12? More details of reinforcement? We kind of split reinforcement into two separate chapters, and they're the bookends of all our design codes. So it's kind of a strange thing. We don't have a roadmap. But we all know what to do, right? That's what we learned in school. That's what we learned in practice. So in the 2011 code organization, we've got specialty chapters. Think about it. Do we even have a member-based code or a behavior-based code? Oh, well, if you'd asked me years before we started, before I knew better, I would have said we have a behavior-based code. We have chapters on shear. We have chapters on torsion. We have chapters on axial load, right? But we also have member-based. We have a wall chapter. We have a slab chapter. We're basically half and half. We want to move fully to a member-based code. We all know what the 2011 code looks like. How many people own a 2011 code? Yeah, we should almost all raise our hands, if not an 08, right? I have in my hand a 1963 code. No, this is not just one chapter or the introduction. This is the entire code in 1963. This has a couple special meanings to me. I was born in 63. What else? I have two versions of this code. One is my dad's. He was a structural engineer. The other is the one I have in my hand, Fosler Kahn's, the great engineer who designed Hancock Center, Sears Tower. I'll pass this around if you want to take a look and see what did our history look like. Feel free to look for your favorite provisions. Most of them are still in there. My dad learned on that code. And he used to always tell me, well, one of the things when I said I wanted to be a structural engineer, he said, Larry, you have to learn the codes. And he said, you have a choice. You can have a summer job, or you could read all these things and I'll quiz you on them. That's how I started to learn a lot about codes. And he used to say, the reason it's all text, and I'm like, where's the pictures? Where's the tables? He says, it's all text because that's the only thing lawyers will accept. Well, we've gotten a better position on that we can look at figures and tables. That's the way we think. So what we have is the problem of a code where you can't find the tool you need. You may know the tool, you use it, but if you're looking for one you haven't used recently, it's buried somewhere in that toolbox. So what are the goals of the organization? Emphasizing on what Randy said. Find the information you need quickly. It's for you, the designer. Increase the certainty that you're done. That's the biggest problem we have with students and practicing engineers. I spent more than 20 years training young engineers. And the biggest problem I found? They didn't know when they were finished. You have a beam. When do you know you've finished all the provisions? They're random throughout the code. So it's time to clean the garage. So the reorganization begins. Hopefully we end up with a garage like this. But what's in it? Well, what we did was we took all the provisions that relate to one topic and we put them in one box. Think of it as a chapter. So when you are in the beam chapter, there will be a chapter called beams. It will cover your flexure, your shear, your torsion, your detailing. Everything you need to know to design a beam. You start at the beginning of the chapter, you work it like a flow chart. When you get to the end of the chapter, guess what? You're done. And you haven't missed anything as important as anything. You know you're done. So what does the reorganization look like? We've got chapters on general. We always have to put the guidelines out there. What are the covered? We're going to talk about systems. We haven't talked about that ever before in the code. Members, as I mentioned. Joints and connections. And this thing we keep calling a toolbox. Get more into that. And then we're going to talk about construction at the very end. So, the general chapters. Scope, notation, terminology. You know, the stuff you read if you can't get to sleep. But it's so important because it outlines what the code will cover. Systems. We're going to talk about a new structural systems chapter. We're going to talk about loads and combinations, analysis, which is greatly expanded, and of course, earthquake-resistant structures. So structural analysis, we're going to actually, for the first time, even identify finite element analysis. We have all been using finite element analysis, and the code has not explicitly said it's good to go. And what do you need to do to say it's good to go? So we cover that. Members. We're going to have all the different members in our own little chapter. But that means some's going to be repeated. Shear, topics like that. That's where the toolbox may come in handy. Well, let's take a look at an individual chapter. Columns. We all know how to design a column, right? That's what we learn in school. We're good at that. Well, wouldn't it be nice if we had everything in one place? So we're going to have the scope, defining what a column is. We're going to have general, the parameters. Design limitations, what is not covered or what's the big and small. Required strength, that's the meat and potatoes of the design. Design strength, now we're actually doing the interaction between flexure and axial load. Limitations, how much steel can you put in? What's the minimum number? These are all things we know, but they've never been tied together in one place. And then, most importantly, all the detailing you need to know for that column will be in that column chapter. This is one of my favorite photos. It's one of my projects. One of my good friends there is in the picture. He designed that column, and the first time he's out there in the field going, I designed that? That's what it looks like? And of course, anyone in here from San Francisco will look at that and go, that's not enough steel. Needless to say, it's a Chicago-type column. And best thing about this is we followed some good discipline set down early on when we started the reorganization to make the member chapters look alike. So everything I just said about columns has its twin in beams. So the flow will be the same. And you know what? I'll be honest, I don't look in the code every time I design. I look something up if I need to. But think back when you were a student. How hard was it to learn the code? And think of it, there's even more code now than when I was a student. How do they do that? They still only have 4 years or 5 with their masters, right? Well, the best thing about this is it'll be easier to learn. You'll have your class on beams, and it'll just be the same. And when you have your class on columns, it'll look like the same flow with new rules. Cool way to do it. You've seen this already today. You may even see this again. This is that typical column detail. And you have to go to all these different places, and hopefully you know them already. And if you already know them, why are you going there? To solve this. Well, the problem is we need to bring out a crystal ball and some magic mumbo jumbo. And everyone say with me, abracadabra. Come on, 1, 2, 3, abracadabra. We'll take all those same rules and we'll put them all in Chapter 10. Organized in the way you would design and detail that thing. We're not changing the final product. We're changing the process to make it more coherent. Joints and connections. We're going to talk about joints. We always have, so they'll have their own special place. Anchoring the concrete will move from an appendix into the main body of the code. You'd be amazed how many people are afraid of using anchorage to concrete because it's an appendix. They're not sure if it's law. Of course it is. But moving into the main body of the code gives it more weight. Organization will have this thing called a toolbox. That's where we put things that you use almost everywhere. You go to the toolbox with a reference, and then it brings you right back to where you left off. You only have to keep your fingers on 2 pages, not 6 or 7. So these toolbox factors have our strength reduction factors. Strut and tie modeling. One of the most powerful new tools we have in the code, right? It's an appendix. We're going to move it into the code. So what you do is if you're in a member chapter and you need to design something that's in the toolbox, it'll send you right to that specific section. You follow that section, you go right back. There's no 6,000 loops. Then construction. My dad used to say the 3 rules of structural engineering are constructability, constructability, constructability. But the trick is, really, ACI 318 is written towards the engineer, not to the contractor. So the construction requirements should really be communicated on the contract documents. In 318.11, these rules to the contractor were intermixed throughout the code, and you didn't know if you found them all. What we're doing, and it's not an easy task, my hat's off to the people who have to do this, they're looking and finding all of them and putting them all together in one chapter. So if you're doing your construction documents, you go to this one chapter to find the things you should put on construction documents. If you're a contractor, you know where things should have been without having to know how many pages of code. It'll all be in one place. Again, my hat's off to those working on that. Not an easy task to find it all. Style. Has anyone ever said code and style in the same sentence? Well, when we started the process, we wanted to get a style. So for example, this is an actual section of 318.11. I don't expect anyone to read this. And if you do read it, I don't expect you to understand it. It gets confusing very quickly. We will replace that with tables. Instead of if, then, does, if, then, if, thens, else's, all tableized. As an engineer, I can understand that pretty fast, right? That's how I think. This one is a personal favorite. This is a 318.11 code requirement. I'm going to read the bottom one there. It says, the following provisions of this code shall not apply to pre-stressed concrete except as specifically noted sections, those. How many fingers do you need? Chapter 13, sections this, except that certain sections of, as applied, noted in. Computer programmers can't follow that. How is an engineer supposed to follow that? Holy mackerel. So what do? In 2014, we're going to expand it out so it's a distinct set of rules for each condition. In English versus Swahili, all in one place so you don't have to go to 6 chapters for one provision. That's the reason. So what are the benefits? It's now going to be organized from a designer's perspective. Easier to find specific requirements, but just so we're clear, if I already know what I'm doing, I don't need to look at the code, I still don't need to go to the code. We're not changing the process. We're changing the organization. We're going to put it more intuitive. So if I don't know, it'll be where I expect it to be. When I'm looking for something in Chapter 7, it won't be lying in Chapter 2. And we're going to reduce those nasty cross-references. You know what those things are, right? That's what I just showed. We have to go to 6 places to figure out what they mean. And then when you go there, you never knew when you had to come back, right? Now it'll always be clear. So we're going to try to save time. We're going to make it easier to learn and teach. Do we have anybody in here who teaches, either at a university or at their own place of work? Is it easy to teach the big code, the 2011? Yeah, because you've been doing it for years. You've got a few years on it. But the point is, we're going to try to make it easier to teach. But the hard part is you got to redo your class stuff, right? So where is our schedule to publication? Right now, we're on our final legs. We do a big applause each time we finish a chapter. Getting there. Public comment period's coming up. I do believe it's been accepted by the IBC for 2015. That was a big accomplishment in the last week or so. Thumbs up to ACI. Publication fall 2014. This time next year, you will be able to get a copy of it. It's going to be published in English and Spanish, U.S. customary units and SI units. It will be available in a variety of formats, printed, enhanced PDF, many others. We're going to talk more about that next talk speaker. So I want to finish up thinking about the future. Real generosity towards the future lies in giving all to the present. And to those that have worked very hard on the reorganized code, they have not done it for themselves. And they've spent a lot of time balloting and writing. They have done it for the future. And I applaud them, and I thank them for their hard work. And I thank you for your time and interest today. Yes, we have moved questions to the end, and so for the next speaker, I'll pass it to Randy to introduce.
Thank you, Larry, for that. The next presentation is going to be done by Allan Bommer. He is the, I guess, a director of development for Bentley Systems. And I like to, he's actually on Subcommittee D, but I appointed him as a chair of a task group to look at broadening the beyond hard copies and some of the PDF versions to look what else we could do in the code. So I call him my token programmer. So we appreciate that he has had that capability to bring towards the committee. So Allan, I'll let you come up and introduce your presentation.
Right, this working? Thank you, Randy. I'm not as loud as Larry, and I just found out I'm 1 year older. I didn't know that. But I am the token software guy on the 318 group. I'm not on the main committee, in the subcommittee. All right, so as I'm getting situated up here, I want to talk about a new product we have. I call it a product, which is we're calling it E318 right now, and it's going to be what we call an electronic version of the code. And I think it'll greatly enhance your ability to both use and to learn the code. But first, just a little background, you know, what makes a good building code. I think you'll see that Randy and I didn't coordinate our slides too well. A little bit of duplicate material, but not too much. So good building code has to be, you know, appropriate, safe, and reliable for our current knowledge, and obviously relevant to our current construction practice, relevant to our current design practice, and economical, both in terms of design and construction. So all these are things that change over time. We use the word current in all those bullet points. And so as these things change over time, the code changes over time. And I want to take a quick look at codes over the past 100 years. It's a little bit duplicate of what Randy presented, but I think I can put a little different spin on it. So 100 years ago, the situation was that concrete was a very proprietary thing. Different companies had different systems. You contracted with a company to both design and construct your building. And there was some need to level the playing field and be able to compare these proprietary systems. And so we ended up with the National Association of Cement Users, the parent or the predecessor organization to ACI, coming up with the standard that Randy mentioned this morning. It is pretty interesting to look at a 14-page code and say, yeah, they've got most stuff covered here. It's also somewhat humbling to see how much people back then knew relative to what we know today. We think we know so much, but they were pretty amazing people. Jump ahead 50 years, and suddenly we've gone from being more proprietary systems to concrete's a real workhorse material, from everything from slabs on grade to high rises. And obviously in those 50 years we learned a great deal. And so the code, 1963, 1 year after I was born, it's now 10 times longer. It's got some commentary. It's got a lot of references. The code is becoming more based on research than it was 50 years before. Now we jump ahead to today, and obviously in the last 50 years there's been a huge amount of progress in concrete technology. Our materials and our practices are totally different than they were 50 years ago. We also have on the left side of the image here, we have a new process, new tools that all of our designers and constructors are using. BIM is big. Obviously we're using software tools to analyze and design our structures. So concrete today is pretty different than it was 50 years ago. So our code is a mock-up of what the 14 code will look like. Certainly it's much larger. It's now 500 pages, maybe 3 times larger than it was in 63. A lot more references. The code is much more based on research than it was in the past. But we still have a code that's relevant for today's practice and today's construction. But I think, you know, in the last 10 years we've become a little spoiled. We want information to be served up to us in an easy way. And we expect to be able to carry that information with us, access it everywhere. And so we need some more tools to make 318 acceptable to us and easy to learn for our current generation of practitioners. And that's why Randy asked us to look at creating this E318 is what we're calling the document right now. So E318 is basically it's an electronic version of 318, but it's got those conveniences that we expect in a modern document. So technically, what is E318? It's an EPUB document, and EPUB is a electronic document format. It's analogous to PDF, but a little bit different. Well, a PDF is something like a paper document that has been made into an electronic form. EPUB is more towards a website that's made into a single file. And it also has the document-like characteristics, but you can have the the functionality you get in a website. And like PDF, there's free readers for all the platforms you're used to, whether it's desktop or mobile. And like PDF, some of these features of these free readers may vary. So if you look at a document on one system, it might look a little different or might have a few different features than another system. So at its heart, E318 is 318. The text is all identical. It's going to be actually produced through an automated process that takes the 318 text and produces both the regular 318 that's get published into paper and PDF, as well as this E318 document. Although, because the E318 document doesn't go through a legal process the way 318 does, it might not be considered a legal document, but I don't think that's anything you need to be concerned with. And of course, it's got the added features in it, which is the primary motivation why we did it. So what are the features? Well, the EPUB document format itself comes with a lot of just what I'd call convenience features. If you don't like the font that 318's in, you can change the font. If you don't like the font size, you can change the font size. You can change the background color, the text color, things like that. And then the pages will automatically relay out for themselves. So with E318, you're not going to want to tell somebody to go to a certain page number because the page number will be different depending on what they're looking at. Search, that's a minor feature, but it's going to be handy with the new code. And a bunch of, I would call, convenience features that are maybe somewhat platform independent. If you buy E318 from iTunes, you could put it on your iPad, maybe add some notes to it, and then you can use it on your iPhone, and those same notes will appear on your iPhone. So kind of things that modern documents have for us. Now, go for a few more of the niceties that come with the EPUB thing. We have navigation. You can easily get to any part of the code. You can add notes to the code. So it might be you will have a copy of the EPUB version of the code in your office, and you add notes to each section. It might be, for our office, the spreadsheet to do this calculation is located here. Or it could be, our office never does this provision. We always take a more conservative route, something like that. So your office can, in a sense, create a customized version of 318 by adding these notes to it. Bookmarks are a minor feature, but might be helpful. And the little slider at the bottom allows you to quickly get to anywhere you want in the code. One item that's not EPUB standard that we're doing for 318 is these little pop-ups, what we call them, in the industry, in the software industry, we used to call them tooltips, but these are a little more sophisticated than that. But at the beginning of every section, there'll be these pop-ups. One would be for definitions, so convenient to anywhere you are in the code, there'll be a list of all the code definitions. So if you find a term, you can easily get to the definition of it if you're not clear about it. Similarly with notation, if you see something in an equation, you're not sure what it's defined as, you can jump to it quickly because there'll be these pop-ups nearby. And references as well. That one might not be as useful, but they're convenient there for you. What's maybe more interesting are the in-document hyperlinks. So you see in this image, there's a bunch of hyperlinks in red, and they're coded red to indicate that they're actually going from one place in the document to another place in the document. And so the types we have, there are links to other sections. With the new organization, Larry mentioned that we'll have these toolbox chapters. So you will be going often from a member chapter to a toolbox chapter. So in this, you'll be able to jump right away from the member chapter to the toolbox chapter. Links to the commentary. The ACI has come up with a very nice way to do this, I think. It's if you look at a code provision number, if it's in red, it's a hyperlink to the commentary. So you click on the provision number and it goes to the commentary for that section. And similarly, if you in the commentary, you click on that provision number and it goes back to the code, which is very nice. And of course, when you're doing this navigating, you've got to get back to where you were. And so there's a page back to the previous page. We also have the hyperlinks in blue, and these blue hyperlinks indicate that it's a link to something outside of the document. So E318 is going to come with a number of references bundled into the document. So for here we have, let's say, a Concrete International article, and we got the blue hyperlink, so I know that reference is included in the E318 document, or in the E318 product. So we can click on that and go right to that reference without having to go search for it in your library, or if you don't own it, you're just being out of luck. So there we click on that, we go straight to the Concrete International article. Probably about 40% of the references in 318 will be included, bundled in to E318. These are going to be ACI references because ACI owns them and has the ability to publish them. And primarily these will be things like structural journal articles, Concrete International articles, and smaller committee reports. Large committee reports won't be included. Things like ACI 301 won't be included. Being a software guy, I like to give a demo, but because if you don't give a demo, people think you're just lying. It's just smoke and mirrors, that you don't actually have a presentation. But our technology today wasn't quite set up to do a live demo, so I've got a little recording here I'll do. It's about 1 minute, and I'll just kind of illustrate the features that we've got. So here we are on the iPad. We're browsing through our collection of 100 ACI documents, finding the one we want to go to. We open the document, we're flipping through the pages. This is actually not the 318, it's a different ACI document. We're going to go through the definitions section. We can scroll through the definitions for this section. And we go to the notation, same thing. The notation we can easily scroll to, and the references, same thing. And we want to try our link to another section, so we're jumping from one section to another. And then we can jump to the commentary by clicking on the reference number. And we want to link to a reference here. We're clicking on the code reference to ICC. And we're in there. We click on a blue hyperlink, so we're going somewhere outside the code. Here we're actually going to a website, the ICC website. We go back. We want to click on the back button to get back to where we were. Now we're linking from the commentary to the code by clicking on the code provision again. And we're more navigating because we want to go back to the end to look at a reference. Go to the top of the page is the blue reference. This means it's a document outside of the code. So we go to the reference. We can scroll through it and read the reference. And then we can go back to the code. So that highlights pretty much all the features of the new E318 document. So you're all going to want to know now, we've got this nice product. It's got all kinds of stuff in it to make it easier to learn the new code and easier to use the new code. What's it going to cost? And I don't know what it's going to cost yet. But we know that we've got a commitment that we want to make it very attractive because we want you all to get it, because we want you all to have as easy a time learning the new code as we can make it. And that's all I have for today. I think it's time for questions for the first session. Is that right? Okay.
Thank you, Allan. So at this point, we've got lots of time, and
Allan, on the EPUB, is there any plan on linking that with other documents like ASTM documents that we can license and bundle together?
Is this one working? Yeah. Right now, there's not a plan to do that, primarily just because the cycle is so rushed that we don't have time to go to these other organizations and get permission to distribute their documents. So I think that could happen in a future version, but right now it's not. You will probably have references to their websites or links to their websites where you can get those documents if you don't have them, but they won't be bundled at this, in this cycle.
I'll try to bundle my questions here. First of all, I'm curious about the, I may have missed it in the slide, the EPUB version of the code doesn't go through the same review. If there's a mistake in EPUB version and somebody designs to that mistake, I assume that means they're not compliant with the code.
The answer on that is going to be very clear. There will only be one official code, and that will be the printed version.
That was my assumption.
All other versions of the code will be not official.
Yeah.
The only official is the printed version.
AIDS, but not the code.
But
not
our
the law,
hope
not
is
the law.
with the we always know there's typos, but the electronic code will be created directly from the electronic version that makes the printed version. So less likely of translation errors.
Yeah, I just would suggest we make that real clear right up front to anybody that's using the document. The other thing I was curious about, and I'm not sure which presentation this goes to, but I don't see any trend or mention of including fire design provisions now or in the future. Is there any comment on that subject?
I'm sorry, including
Fire, design for fire.
That's covered by the IBC requirements currently, and ACI 318 is adopted by IBC, so directly you already have them. Repeating them is not beneficial at this time, but certainly as new business, one can always look at new things for the code.
All right, thank you.
In the line of what Jay was asking for the EPUB, is there going to be work done on the Spanish version?
You know, I don't actually know, but because the process of creating it is automated, I would think that would be able to be done without too much effort. So I can't commit to it, but I think it's a practical thing for us to do.
I'm not a structural designer, but is there any possibility that with 318 it would be able to be developed into a computer model that could be compared against structural designs that are developed in BIM? And so you could take something, for example, based on the Indian code, run it against the 318 model, and see if everything complies with 318?
I guess I'll take that. That is certainly the direction the industry is going with being able to define structures in like IFC or something like that, but it is definitely a long ways off. Right now, if you want something like that, you need to go to some proprietary product that understands multiple codes. I can sell you one.
In one of the presentations, you mentioned that there is a section for new technologies to make it their way into the code. What's the process to do that?
Yeah, the process would be like any, if you have a technology that you would want to introduce into the building code for consideration, that process really isn't changing from what it has been. Anybody can introduce an idea and for consideration. It's up to the chair of the committee to assign it to an appropriate subcommittee for review and vetting, and if it gains some traction, then it could potentially become part of the code. So that process is really an open process and can be done by anybody. What I wanted to emphasize about new technologies in terms of was the formatting of the code. If you have something relative, for example, let's take beams, then it's going to be a logical place within that chapter where if that idea is approved by the committee, then it would have a place in the beams chapter laid out for it. It would have a logical location. So it's really the idea that of the formatting of the code and how we have laid out the outline, whatever, to make it easier to put it in. Subsequently, it'd be easier for end users to know that that technology has been added and where it is located.
May I elaborate on that? Sure. The end of this process is only the beginning of the next process. We have a lot more work. I mean, we all think we do perfect, but we know there's going to be mistakes. We're going to have to correct those. We're going to proceed forward. What we've really done is not redefine the wheel, but make the wheel a little more rounder so it'll roll a little better into the next 50 years with the idea of bringing in new technologies. I mean, even adhesive anchors were a very difficult thing to find a place into the code, right? Now they'll actually have a location for anything of those type of technologies. So what we've done is really redefine the drawers in your desk, reshuffle the paper so that you're able to continue on and work more efficiently. So the end of the 2014 is the day we start the next code cycle. And it's one of those things that never ends, and there are many people in this room that have lived through many code cycles and they can understand what we're talking about. and it's always going to be a challenge going forward, but it's one we look forward to and not be afraid of. Great question. Thank you.
I might add one thing to Larry and Randy on this issue of new technologies in the code. I think it would be, I'm not sure it's appropriate to assume that every new whatever, widget or device is going to have a home in the code. I mean, I think that's impractical when you think about it. There are just lots of new technologies that develop. I think the code has to be written in a way that permits use of those devices if in fact they will comply with the intent of the code. That's why in the current code 318.11 and this provision will exist also in 318.14, there is a provision for approval of special systems, so that even though a particular technology is not explicitly listed in the code, there is a process for getting approval to use that under the code. And I think that has to remain, because I don't think it's possible to have every possible option considered, or that 500 pages is going to get a lot longer.
Tony, absolutely right. The whole idea is to keep the things that are the windows open, so to speak, that allow for that new development between code cycles and even to add new things in. Our founding fathers, so to speak, in the code process always set up these appendices for new things that are coming in and old things that are going out to allow for transition periods. And the idea of allowing for expansion is important to build in beforehand. Great comment.
Yeah, I'd like to just, Tony, you're absolutely right about that, and certainly don't want to convey the message that any widget out there is going to be automatically accepted. I'm thinking more in terms of if there's a new widget, such as a new type of coupler, for example, that really gains traction, instead of having development links or some other sort of thing, that it would have a place that it could find a home, and then there would be a place within the body of that chapter where it could be identified, and identified more easily by the end user. But absolutely correct what you say.
Yeah, and I actually did have a question for Allan, just on the EPUB. We talked about the advantage of being able to do pop-ups to definitions, and so will these definitions be tailored? Like EPUBs right now, you know, you can grab a definition of any word, but it's a standard dictionary definition. Whereas in the code we have words that are used uniquely and specifically to the purpose of the code.
We looked at doing what we'd say pop-up or tooltip definitions for defined terms in the code, and for this version we've decided not to do that. There were two motivations for that. The first motivation is that there are a huge number of defined terms in the code, and therefore there would be hyperlinks almost everywhere. The second motivation is that we really want to get E318 out at the same time as the code, and putting that capability required some manual work, so that we weren't going through some automated process that picked out terms that maybe weren't appropriate use of the defined term. So this version, the definitions will all be in, notations will all be in one place, but maybe in a future version of E318 we'll have them as pop-ups for actual defined terms in the code.
Most of the changes which you were talking about is changing the format, which is great. I mean, that new proposed format will be much more user-friendly. The question I have is, are you also doing some changes in the substance? For example, the service limit states. There has been quite a lot of work done in bridges for AASHTO, and I think that a lot of this is applicable to building structures too. Like we are talking about LRFD format for the strength limit states. It's there and nobody questions this. for service limit states is basically allowable stress design. I mean, the way it is. The philosophy of defining these service limit states changes the approach, and then that may also change the way it will be presented. Are you including that in the new version 2014? Thank you.
Dr. Novak has asked a question about whether we've had other, besides the reorganization, have there been other technical changes that are occurring? And the answer to that is yes. We've actually processed quite a few new technical changes, some very small, some much more broad. Specifically addressing serviceability limit states, the answer is no. We simply did not have time in this code cycle. That may be something that the next code cycle, code committee will want to consider. But to give you some examples, and you'll hear a little bit later this morning about some of the changes we have, we introduced this chapter of structural systems, which I think really gives a much better idea of what we're trying to do in the code. Again, it's not a long chapter, but it does describe performance requirements that are required of building structures to meet in order to be compliant with the building code. And that includes having things like a lateral load system, a gravity load system, having stability, and other types of limit states that really were assumed but not really implicitly defined in the code. We have another chapter, again, on diaphragms. Everybody knows that a slab, for the most part, we design for gravity loads, but it acts a lot in lateral loads as diaphragms. We did not have a chapter on that. We specifically define what is required. Dr. Maley, who will be the next chair of 318 in his subcommittee H, developed that chapter to define things like collectors and what forces and detailing requirements you need to get in slabs, from the slab into walls or to other members. So we've got a lot of other additional technical changes. You know, the emphasis certainly has been on this reorganization, and that's been a large part, but part of that process was to define any gaps that we had, and those were gaps, specifically structural systems, the idea that we have to have lateral load and gravity load systems in a building, and then also the diaphragms, what is it that we want to define in terms of designing diaphragms was something that had been missing in the code. So those have been added. And then other smaller changes that have evolved from subcommittee work that would be kind of considered normal processing of technical changes because of research or practice in the industry.
Yeah, sure. Totally agree with Randy saying. And you may have a corollary now. You've heard the question, you've heard the answer. You may be saying, okay, you did make changes. How am I going to find them? Well, ACI staff has been working very, very hard on creating a matrix that will take every provision that had a number in 2011 code and where is it in 2014. So you'll be able to say, oh, that's my favorite provision, if you have a favorite provision of ACI. I know, actually, I do have my favorites. You have and you can find where it is in 2014, and then also what is new, so that things like that will be easy to find. Because the worst thing you want to do when you get a new code is say, I have to read the whole thing cover to cover, and then now I have to read the old one and see how they compare. Insomniac's dream. So ACI staff has worked very hard to help us find these new things so that they'll be itemized, and you'll know where the old ones are and where they've wound up. That'll help with the process. Yes?
I have a question. Guillermo Santana from Costa Rica, and as far as I see there in the international list, we either became the 51st state or we're no longer in the internationally considered. I have a question concerning the legality or the use of the electronic version, whether or not it's legal. And the question is whether or not a PDF, plain static version of the code is considered right now as a legal document as compared to this EPUB, which you move across, up and down, very flexible, but is it legal? And I think it is an important question because you're actually telling us it's a fine instrument, very nice, but it's not legal if you say that you designed it using your EPUB application. So how do you go about this? I don't know if is the question clear? Do we know about a static PDF? I mean, just a plain
I can't
copy.
answer your question particularly on council, but what I can say is if you look at the text in the PDF version or the text in the EPUB version, and it's identical to the text in the printed version, you know you're fine. So the process in which the code is adopted as a legal document, they're probably having a paper document that they adopt, but it's really the content that's what you're concerned about. If you design something with the EPUB version and the content is the same as the paper version, you know, you don't care whether you design something with a legal document or not because it's equivalent to the legal document. Is that enough of an answer?
Well, I certainly don't want to be accused of giving legal advice up here, so it's have to be a little bit careful. And what Allan said, I think, is exactly the case. I mean, it is very clear that really legally the printed version is the adopted version. And the reason is because that is the version. ACI 318 has no force of law other than the fact that it's adopted by the IBC. IBC is going to be adopting the printed version of 318, not an EPUB version, not a PDF version. It is the printed version. I think it's an interesting question and probably one that we need to cycle back perhaps with ACI counsel on this, but that's the way it's been explained to us, that for now it has to be the printed version of the code is the legal document, so to speak.
And I, for one, though, welcome the electronic version. I, for one, welcome the electronic version because I can see the case. I'm traveling to a project site. I'm down the hole, and the contractor asks me and says, instead of 6 by 12 cylinders, I'm going to use 4 by 6 cylinders. How many more cylinders should I test? Well, being able to look that up on the e-publication version on my iPhone, which is in my pocket anyways, beats the heck out of telling the guy, I'll get back to you when I get back to my office. He wants to know there. Legal aspects, I'll leave that to counsel. But certainly from an engineering aspect, having that searchable on my phone is going to make leaps and bounds in our accuracy of what we do and communication.
So Larry, this means you have read chapters 1 through 6. One issue I think related to the discussion of whether the EPUB or the PDF, it probably depends on it may wind up depending on the governing jurisdiction, because just as the ACI code has no legal standing unless it's adopted, the IBC has no legal standing unless it's adopted. So what happened, at least in U.S. practice, there is a governing entity, whether it's a local jurisdiction, a city or a village, or whether it's a state. We don't have a national code. So it probably depends on their interpretation of what's allowed, I would guess, at some point. But again, I'm not trying to give legal advice, but I don't think it's quite as simple as it might be in other countries where they have a national code, and that could be determined based on what the national code body decides.
We certainly encourage people to have not just the electronic version, but also the printed version, because that is the official code, whichever way we go. So having it on your phone and having the official one on your bookshelf, I certainly wouldn't say you should just have an electronic version, just natural. That's right. Exactly.
To give an example, and this might or might not be a possible problem, if you can change the font, then that means you're using a different character set. And if the Greek letters aren't mapped the same way, your fee might become a row or something like that, or some kind of substitution. So that could be one reason why you need to be careful about changing character sets.
To get a little technical here, I'm sure we're using Unicode and therefore that issue doesn't exist.
If I understood right.
That's why we have a programmer working on this. So whatever Unicode is. So.
He may need an army behind him soon. I would fully support, I thought I heard that you're developing a concordance essentially that allows you to compare current provisions against 14 provisions against what was there before. And that's going to be critical, I think, for people to understand and accept this document going forward. So any work that you're doing on that, I would encourage you to make that happen.
Yeah, that's in the works. It's been developed. It's going to be available in a lot of different forms, probably even bundled with some of these things, but also available to the general public on the website, even though they may not be ACI members and so forth. So that's something that's definitely being worked on as we speak.
And just a comment to the legal issue, which obviously is complicated and we won't solve here, but one thing to consider is when you publish the code, you usually publish errata soon thereafter, and then sometimes you publish supplements, and a static PDF can't deal with that. An EPUB's document could. The only point I was trying to make earlier was that it puts a pretty high burden on you to make sure that the EPUB's version is doing what it's supposed to do, because if somebody gets stuck, they're going to be held to the printed version, not to that thing.
We haven't discussed this yet, but I believe technology is in place for when you have your iPad and that kind of thing. You get notifications of updates to documents, and you should be able to get notifications for updates for ACI documents as well. I can't promise it, but I believe we'll be able to do that.
One follow-up question to the issue of new technologies. We know there is an ACI Committee 440 on composites. We know there is a lot of interest in non-corrosive reinforcement. And the question is, has any thought been given to, for example, allowing type of reinforcement, carbon fibers or carbon epoxy reinforced type reinforcement that includes these materials?
Well, I guess we've had the hardest question left for last, apparently. So certainly these have gained a lot of traction, FRPs and non-metallic reinforcements, and even other types of more robust, non-corroding types of metallic reinforcement. And I think the answer is yes, there's been consideration. And it goes back to some of the thoughts that came up with Tony Fiorato's question about, are we going to add that to the code, or is there a mechanism such that we adopt provisions, or just like we do with adhesive anchors or other types of anchors, we reference another document that is a standard. I think that's probably going to be the more appropriate choice as we move forward if we really want to adopt some of these newer technologies that do take quite a bit of understanding and calculations in order to go through the various processes of a reasonable design, and that it's going to be incumbent probably on those committees to turn those into standards or codes in which 318 can reference those. I fear that if we go and try to adopt every little widget, certainly FRP is a nice widget, non-metallic reinforcement would be a nice widget, but it will grow the code even more. So I kind of foresee this as adoptions of other standards.
Okay, it looks like it's almost 10 o'clock, and that takes us to the end of the webinar. At this point, I have just a couple of quick announcements. And one of them is that after the workshop is completed, all the participants will be informed of a link so that you can access a PDF of the presentations, and that is provided each speaker gives a permission, and most of them have already given that permission.